Chapter 1. The Hidden Frequency. You lie in the quiet of evening, aware of the space between each breath. You feel something unspoken pulsing beneath the ordinary hush. You sense a rhythm that neither ears nor eyes can grasp, yet it moves through you like a slow, invisible tide. In this moment, the planet itself seems to breathe with you. Scientists call these signals infrasound, vibrations below 20 Hz, stretching beyond the threshold of human hearing. Experimental physicists first charted these waves using sensitive instruments, tracing undulations that sweep through the atmosphere and Earth. You imagine their measuring tools, solitary devices mapping invisible contours that slip under our notice. These infrasound waves have wavelengths that span hundreds of meters or even kilometers. At 1 Hz, the wave travels as a single cycle per second across 300 meters of air. Such expansive motion feels more like the breath of continents than the chatter of everyday sound. As these slow patterns drift across land and sea, they stir hidden resonances in rock, ocean currents, and even in the fluids of living bodies. You contemplate how these gentle pulses brush against your senses. Though inaudible, they can resonate within you, nudging mood and memory. Infrasound researchers have noted that specific frequencies can induce a sense of awe or unease, as if the earth whispers secrets at the edge of perception. You trace that subtle thrill along your spine. In your mind, these deep waves become an undercurrent of curiosity. They remind you of a hidden layer beneath daily life, a reminder of vast processes at work. For a moment, you feel the planet's chest rise and fall in alignment with your own, as if the world and your breathing share a cadence. This soft unity deepens your sense of belonging. You rest in that discovered stillness, aware of the planet's secret heartbeat, and you hold on to this faint resonance, knowing it beckons you further into an unseen world of sound, and you wonder what deeper harmonies await for listening. Chapter 2. Whispering Waves. You stand at the edge of a frozen plain under a pale night sky, feeling the soft murmur of energy currents in the air. Around you, tall antenna towers hold silent sentinels for directed radio frequency beams. Each pulse you sense is a pattern of microwatts and megawatts, tuned to frequencies between 3 and 10 megahertz. In science, these waves gently interact with charged particles high above, in the ionosphere's F region, near 200 kilometers altitude, where gases glow in faint ionized color. You notice that each beam emerges from a phased array of hundreds of dipole antennas, their positions calculated with care. By adjusting the phase of each element, the system steers the wavefront like a conductor guiding an orchestra. This science relies on constructive and destructive interference, where peaks align to amplify and troughs cancel, to shape slender curtains of power. You feel a gentle heartbeat in the field as pulses merge and diverge in rhythmic harmony. As you breathe the crisp Arctic air, you imagine the beams slicing upwards, heating electrons in the upper atmosphere by mere degrees. The ionosphere, a layer of ionized gas, nourished by solar ultraviolet light, responds in kind. Here, scientific instruments record subtle changes in electron temperature and density, revealing how energy moves through the sky. In these heights, the curtain of high-frequency whispering shifts, painting invisible pathways that only specialized receivers can decode. You sense these pulses as whispered conversations with the sky itself. Engineers modulate amplitude and frequency to nudge the upper layers, generating ultra-low frequency waves that drift back toward Earth. Real science calls them elf waves, carriers of secret signals that once crossed oceans and ice in covert experiments. The landscape falls into a hush, each antenna a silent storyteller. You stand between frozen ground and charged heavens, listening to the lingering resonance that hints at another secret drifting closer. Your mind opens to possibility, imagining magnetic field lines bending under influence, auroras dancing in response to subtle heating. A new question beckons beyond the horizon. Chapter 3: The Watchful Eye. You lie beneath a vast expanse of stars, feeling the quiet pulse of orbiting machines overhead. In hidden labs, engineers assemble the first spy satellites, part of Project Corona, sparking the dawn of orbital reconnaissance. Each launch slips through night like a silent promise, a silver bullet rising from Vandenberg Air Force Base. You sense the hum of telemetry as rockets breach the upper atmosphere and enter polar orbits, mapping every curve of Earth's surface with patient vigilance. Your breath slows as you imagine the first glimmer of a watchful eye passing unnoticed above. Inside each satellite, a spool of photographic film coated with silver halide spins quietly under cosmic radiation. Light reflected from mountains, rivers, and distant shorelines darkens the emulsion like a secret diary. Every faint line becomes a record of geography, every subtle contrast a map of borders. Developed in mobile dark rooms aboard retrieval ships, these images expose patterns invisible to naked eyes. You understand that the precision of film resolution, down to a few meters, reshapes how the world is known. You trace the path of tiny re-entry capsules as they plunge back through layers of atmosphere, protected by ablative heat shields that glow in fleeting orange trails. At high altitude, recovery planes hover beneath descending parachutes, swooping in with extended hooks to snag each canister. The film emerges unscathed, cradled in rigid metal, carrying secret snapshots of borders and bases. Pilots commit to split-second timing, intercepting objects hurtling at terminal speed. You feel the thrill of a hidden choreography where science meets daring. You sense the gravity of early pioneers who trusted film and orbit to reveal truths once held in shadow. Each secret mission charts a bridge between human curiosity and the vastness above, reminding you that every discovery begins with a single lens staring downward. You breathe in the weight of data carried home, knowing each frame tells a story of power. The night sky seems laden with sentinels, and you wonder what new eyes, precise, patiently await beyond this clandestine horizon. Chapter 4: Thermal Dreams. You close your eyes and imagine stepping into a world warmed by invisible rays, where the air itself holds tiny packets of energy called infrared photons. This gentle glow, beyond the limits of your vision, carries subtle signatures of temperature in every surface. Infrared is one band of the electromagnetic spectrum, a realm this narrative gently unfolds. As you drift along quiet streets, thermal cameras map the warmth of buildings, revealing patterns of insulation and heat loss. Warm windows and chimneys glow like veins releasing vital energy from a living organism. Engineers study these images to improve efficiency, tracing escaping heat to reduce waste and conserve resources. In the hush of night, you hover above sleeping cars and strolling figures. A thermal sensor tuned to around 10 micrometers in wavelength detects body heat at roughly 37 degrees Celsius. Each heartbeat pulses warmth through your chest, an irregular rhythm measured remotely by pyroelectric detectors, mapping the contours of life with no touch required. You glide from residential lanes into factory districts, feeling the hum of machines through thermal contrast. Engines and motors radiate heat according to the Stefan Boltzmann relation, which says hotter surfaces emit more infrared light. You note the difference between red-hot exhaust pipes and cooler metal casings, a visual guide that helps designers optimize performance and limit energy loss. Above the city, you imagine satellites equipped with infrared radiometers orbiting Earth every 90 minutes, collecting data on heat distribution. These instruments measure infrared intensity, converting millions of photons into images that scientists analyze to track urban heat islands and climate patterns. You sense a pulse of global warmth, a reminder that living systems weave thermal tapestry. Within this river of thermal contours, you discover both comfort and caution. Warm corners feel like safe harbors, while unexpected cold spots hint at hidden leaks or drafts. Each variation tells a story of flow, retention, and release. You float between visible stillness and unseen warmth, sensing how life and technology intertwine and reshape your perception. Yet a cooler mystery lingers, waiting to be sensed in deeper shadows. Chapter 5. Silent Beacon. You stand beneath a quilt of grey clouds, your breath tracing silent arcs before you. Beneath the hush, synthetic radar pulses sweep across the land, each a brief flutter of microwave energy. You feel the power of wavelengths that pierce clouds and mist, offering an unseen portrait of hidden terrain. Each pulse you send becomes a messenger, racing outward and back. By measuring the time of flight, how long it takes for the radar echo to return, you learn its distance. This concept, like timing an echo in a canyon, reveals the height of hills and depth of valleys with precise accuracy. But the magic emerges when the radar moves. Synthetic aperture radar, or SAR, stitches data from many positions to create a virtual antenna, hundreds of meters long. This technique sharpens the image so you can discern a narrow path or a winding river that lies concealed beneath thick forest cover. Some radar wavelengths slip through foliage or sift into the ground. Longer L-band waves reveal underground channels, while shorter C-band pulses highlight rooftops or icy glaciers. Each frequency is like a different color of light, painting unique layers of information over the Earth's surface in your mind's eye. Because the Earth curves, radar beams graze the horizon and extend your vision beyond what eyes alone can see. By calculating beam bending and horizon distance with simple geometry, you understand how signals hug the planet's silhouette. It is a partnership between technology and Earth, unfolding secrets at the horizon. In the hush, a distant echo returns, a faint pulse that shifts slightly from the last. This subtle change, detected through interferometry, can map gentle movements. the slow drift of a glacier or a trembling fault line before the earth stirs again. You sense the living rhythm beneath stability. You follow the beam's invisible path as it bends and unfurls around the globe, a silent beacon lighting both known and secret realms. In this gentle glow, you feel the invitation to peer deeper, to trace the next layer of a hidden movement that awaits discovery. A new pulse calls softly, promising another revelation yet to come. Chapter 6. Echoes of Dawn. You float at the edge of consciousness, noticing pulses of energy echoing through your mind. In the quiet of space, intelligent satellites drift along orbital paths, their antennas tuned to radio frequencies between 30 megahertz and 3 gigahertz. These measurements, part of the electromagnetic spectrum, capture whispers of distant transmissions. You recognize each signal as a piece of a larger tapestry, a network of unseen communication weaving itself across the void. As you drift among radio bursts, you feel the pulse of hidden conversations ripple around you. Satellite arrays use triangulation, measuring time delays between multiple antennas to pinpoint a signal's origin within kilometers. This simple geometry, reminiscent of ancient navigation by stars, allows you to map invisible voices dancing across Earth's atmosphere. You trace each pattern, noticing clusters of activity and blank spaces where silence holds its own quiet, subtle significance. Each frequency you follow becomes a thread in a grand design of silent exchange. You imagine radio waves stretching for meters or kilometers in wavelength, oscillating at precise rates like ocean swells. When you tune into just one cycle, you witness how information is encoded by shifting amplitude or frequency modulation, a fact that brings structure to what once felt like chaotic noise. You sense a pattern emerging, comforting and profound. Beyond Earth, you notice some faint signals bouncing off the ionosphere, 50 to 600 kilometers above you. Charged particles there refract radio waves, opening pathways beyond the horizon. This bending of energy feels like a secret handshake across continents. You follow one mysterious wave as it arcs over vast oceans, carrying coded words and melodies hidden within soft static. You cherish each echo, sensing time itself joining this quiet conversation. In the soft stillness, you track a final echo slipping ever so quietly into night. Its frequency moves beyond familiar bands, hinting at a source far from known circuits, perhaps a probe whispering data from the solar system's fringes. You realize every decoded signal bears traces of intention, scientific, poetic, or simply curious. Holding that realization gently, you prepare to follow this fading frequency, marveling at the silent doorway into uncharted realms. Chapter 7. Orbital Shadows. Darkness wraps around you as you drift into the orbital abyss, a silent ocean above Earth. You feel the hush of space pressing gently against your senses, like a deep-sea dive where pressure softens sound. Around you, satellites slip through empty corridors, their paths measured in precise orbital turns. In the faint starlight, you sense them gliding without a trace, each one bearing secrets of geometry and quiet motion. You reach out with curiosity as a sleek shape draws near. Its surface wears a stealth coating woven from radar-absorbing materials called metamaterials. These microscopic structures trap incoming microwaves, turning potential echoes into soft warmth. Thousands of tiny grooves and angles scatter signals, minimizing its radar cross-section. It behaves like a translucent fish in murky water, becoming nearly invisible to instruments. You imagine engineers refining each facet, sculpting silence into the craft's form. You breathe in the stillness of its passage, noting how science and design fuse in hushed coordination. You drift alongside in imagination as each angle matters. Ingenious facets reflect stray beams toward empty space, like branches diverting a breath of wind. Engineers calculate every plane and curve using computer models of electromagnetic waves, predicting how signals bend and break. The dance of physics and form reduces the satellite's signature until it vanishes beneath the radar's threshold. In this silent ballet, technology learns the art of disappearance gracefully. You trace the invisible orbit tracks, concentric rings drawn by velocity and gravity. Each satellite follows a distinct path, a secret highway high above you. Networks of them weave a global grid, sharing data on weather, terrain, or distant signals. In their quiet synchrony, you glimpse patterns of influence and reach, unseen threads linking distant places below. The harmony of motion and purpose offers a subtle portrait of silent governance. You rest in the hush above Earth, steady with wonder at patterns unseen. Cloaked watchers hold vigil in darkness, like whales gliding through midnight currents. Their silent dance shows that power travels hidden, just beyond plain sight. A trembling glimmer of reflected light hints at deeper layers of surveillance, calling your mind and inviting you onward toward the next unseen horizon. Chapter 8. Invisible Threads. You lie back and notice a gentle pulse of light on your eyelids as you imagine particles drifting across cosmic distances and darkness. In this stillness, you sense that each particle, once linked, remains entwined even when separated by emptiness. This is the essence of quantum entanglement, where pairs of particles share properties instantly, as if bound by invisible threads. You feel comfort in the idea that nature can connect the farthest points with a whisper of unity. You recall that entanglement emerges when particles share a common origin, creating quiet correlations that persist beyond space. You recall how satellites have beamed photons between orbiting platforms and ground stations to test quantum key distribution. In these experiments, single particles of light carry cryptographic keys that change on measurement, ensuring any intrusion leaves a trace. This fact reveals a practical use for entanglement. Secure communication across thousands of kilometers, each photon a messenger that guards its secret through its own quantum state. As you follow the imagined path of each photon, you see them bouncing between mirrors and detectors, forming a dynamic bridge of information. You understand that any attempt to eavesdrop alters the photon's state and becomes immediately apparent. This simple principle, rooted in Heisenberg's uncertainty, transforms an abstract science into a promise of trust, where no unseen hand can slip by unnoticed. Your thoughts drift to Einstein's term for this phenomenon: spooky action at a distance. You recognize that he challenged this idea with a question: how could a particle here know what one there does without a signal passing between them? His intuition led to Bell's inequality, later tested in laboratories that featured rapidly switching detectors and entangled photons that defy local realism. Yet you also sense a hint of subtle fragility, for entangled states can unravel through decoherence when they interact with their environment. In that unwinding, the threads seem to fray, reminding you that even the most delicate tapestry can reveal a pattern deeper than you first imagined. In the quiet afterthought, you linger on the notion that unseen weavings in the quantum realm hold more secrets than we yet understand, inviting you to follow their shimmer into the next discovery. Chapter 9. Radiant Secrets. In the hush of night, you lift your gaze to the silent sky, imagining satellites tracing invisible signals. High above the Earth, treaty verification instruments listen for gamma rays, high-energy electromagnetic photons born when unstable nuclei release excess energy. You feel the distance between yourself and these orbiting guardians shrink, while you picture their sensors scanning every flash across clouds. Each gamma photon carries a secret signature, its wavelength telling a story about materials on Earth below. You imagine isotopes born in hidden reactors, each decaying through alpha, beta, or gamma emissions in a delicate dance. An alpha particle, a helium nucleus, drifts from its parent, its charge driving gentle interactions with nearby atoms. In beta decay, an electron or positron emerges from the nucleus. You track this choreography of particles, recognizing that each decay event is a tiny heartbeat in a system of global monitoring. Far below, ground sensors in scintillator arrays convert incoming radiation into tiny flashes of light, each photon a whisper of detection. Neutron detectors use helium-3 or boron trifluoride to register slow neutrons, critical for verifying compliance with disarmament treaties. You feel the solidity of these instruments beneath your feet, their calibrated thresholds set to catch even the faintest pulse. In this way, human ingenuity shapes a quiet watchtower around our collective sense of security. Meanwhile, cosmic rays from distant supernovae rain down constantly, creating a background hum of secondary particles. When these high-energy protons strike atmospheric nuclei, they generate showers of muons and neutrons that drift toward the surface. You feel their passage as an echo, a gentle reminder that Earth is immersed in cosmic conversation. Systems subtract this natural flux to reveal human-made anomalies. This careful calibration tunes your awareness to faint signals of change. Your role is to listen deeply, guided by science and intuition. Beneath your awareness, each decay detected by these networks becomes a secret revealed, a delicate balance between safety and uncertainty. You sense the fragile pulse of global vigilance, an unseen grid of care woven through numbers and signals. A subtle pulse beyond measurement suggests another secret energy waiting to be named, its enigma beckoning you toward deeper understanding. You linger in this quiet moment, ready to follow where curiosity leads. Chapter 10. The Final Orbit. You settle into the soft tension between Earth's pull and the steady path of low Earth orbit. You feel a subtle tug of gravity, around 90% of its strength, letting you rise without floating free. In this threshold, satellites trace invisible loops above your head, each moving at nearly 7.8 kilometers per second. Their motion feels like a heartbeat, a rhythm steady enough to guide navigation and carry signals across the silent sky. In this space, you sense the invisible dance of wavelengths. Satellites use radio and infrared beams, each frequency tuned like a musical instrument. Remote sensing satellites detect heat signatures, measuring temperature changes by sensing radiation around 1 to 2 micrometers in length. Others map vegetation by capturing reflected sunlight in near-infrared bands. You imagine these parts of data weaving a mesh of knowledge, revealing currents in oceans and the subtle shifts in Earth's living skin. You watch as orbital mechanics unfolds in silent precision. A satellite at 400 kilometers altitude circles Earth in about 90 minutes. Its velocity balances the pull of gravity, creating a constant freefall that never reaches ground. The centripetal force holds it aloft, a dance of vectors and mass, physics written in real time. Every slight angle of tilt or inclination modifies how sunlight touches sensors and casts shadows across continents. Your attention drifts to the silent chorus of signals that enable GPS. At least 4 satellites triangulate each position with atomic clock precision, measuring time delays in nanoseconds. You feel how a shift of just a few billionths of a second changes latitude or longitude by meters. This reliance on Einstein's theory of relativity feels like poetry in practice. Time itself warps under velocity and gravity, and your device adjusts seamlessly to keep you precisely on course. You rest in this final hush, where orbit and technology unite in lullaby. Satellites blink overhead like distant lanterns guiding you through the dark. Most low-Earth satellites float between 160 and 2,000 kilometers above, forming a moving canopy you rarely perceive. You feel the delicate balance between gaze and guile. Each instrument reveals secrets while honoring borders between known and unknown. As your breath slows with this celestial rhythm, you sense the gentle promise of new mysteries awaiting you.